Well, thank you for the introduction. And the panel today is about AI, GenAI, and how we're moving to 6G. And uh, there is a lot of work that it's going on. And I have the pleasure to have with me two excellent panelists that have been working on AI for a long time before it was a cool thing, before everybody talked about. And they really are working on it hands-on. So we're going to have, I think, an interesting conversation about what's happening and what will happen, what we should expect to happen as we move to new, 5G advanced and eventually 6G. So we have David Soldani, who is the SVP of Innovation and Advanced Research at Rakuten, and Paul Patras, who is the Mobile Intelligence Professor at the University of Edinburgh. And he also has a startup, NetAI, where he is the CEO. So David, Paul, welcome to the panel.
Thanks
Thank
for
you for
having
having
us.
me.
So let's get started. And why don't you tell the audience who you are and what you do? Paul, why don't you get started?
Yeah, so I think you already did a brief introduction without going into, too many boring details. So I'm an engineer by training. I worked for a large telco manufacturer nearly 2 decades ago now, and then I decided to take a break from that and pursue a career in academia. Did a PhD, and then ended up at the University of Edinburgh as a Chancellor's Fellow slash assistant professor, and then throughout the years I progressed to full professorship. And in the process, because Edinburgh has such a long-standing tradition of fundamental machine learning, and we were building a GPU cluster, I thought this is an opportunity for me to kind of try to solve some challenging problems in the networking domain that were suitable for AI. And that was at the time where I think the industry was not even looking at it. So it was a little bit early days, and there was quite a bit of skepticism, but then eventually things took off. So yeah, that's how the research started, and then to some extent that's how NetAI started as well.
Yeah, it's actually quite amazing how much everybody now is, AI can do without AI. But it used to be a time where everything was seen with a huge amount of suspicion. David, how about you?
Yeah, so thank you for having me, by the way. So yeah, I've been active in the information communication technology field now for about 25 years, and I've been contributing both as an academic, as an industry player. So as an academic, I'm still active here in Australia. I'm a joint professor at the University of New South Wales. And as an industry player, I have contributed to 3G, 4G, 5G, and now also towards 6G, looking at the research, development, optimization, and deployment of mobile communication systems. I was with Nokia for about 14 years, then Huawei 10 years, running the Center Research Institute of Huawei in Europe. And then I had the great opportunity of joining Rakuten, that is 3.5 years now. I initially served as Chief Information Security Officer for Symphony, and then I moved up into the Rakuten Mobile. And at Rakuten Mobile, I'm heading the Next Generation Advanced Research Division. And we have 4 areas of research. One of them is on AI algorithm. The other looks into eBPF, so we program the Linux kernel. We then work on open APIs. And last but not least, we work on 6G, particularly targeting and focusing on the cloud-native aspects, security aspect, and AI aspects of the next generation mobile communication system.
Perfect. So as you see, Paul and David have been working, for real and I mean for real in the sense that they're working really, hands-on on AI in different parts. So let me start with you, Paul. What is that you see happening, from your point of view? What kind of progress are we seeing? AI is work in progress. There is a lot that AI is not yet doing, but is going to we expect to be able to do. But it's a process, and there is a lot of work involved. So how do you see that going? 5G, 5G Advanced, and 6G.
Yeah, so there's multiple things. I think at the moment, the industry is sort of waking up to the realization that networks are becoming quite complex and difficult to manage manually. So it makes sense to look at some tools that enable some degree of automation. And there have been tools like that in the past. But now it's just a matter of being able to, do that automation really quickly and solve some complex problems. So then it makes sense to start to think about how to implement some AI algorithms. And there's probably kind of a bit of a retrofit. So you deploy AI in existing infrastructure. But then, because we're talking about 6G, I think this presents an opportunity to build, I guess, both AI native and cloud native systems, whereby a lot of the functionality now is not necessarily co-located in the infrastructure, but it resides somewhere else, let's say in the cloud, be it public, be it private, close to the edge, or more centralized, where you run some of these algorithms that solve those problems. And in some cases, you can't really get away without running some intelligence really on the device. So if you want to do some very advanced signal processing, that has to be co-located on the device. So then you're building things sort of with AI from the ground up. I think that's yet to come. I think there are a few startups that look at that, to my knowledge, but still the computational cost is pretty high. So I think a lot of things have to happen for things to become practically viable, I would say.
You put a lot of things that I want to ask you more questions about, but let me first get David's impression on the same topic. What do you think?
Yeah, nowadays AI is extremely hot and coming all over the places. So if you think of the 5G Advanced, for instance, release 18, 19, and 20, they have already specified a number of use cases and enabling technologies at the UE side, at the network side. And if you think of, for example, an algorithm around positioning, a traffic steering, traffic management, load balancing, algorithm linked to network control and so forth. So they are now pushed very hard into the infrastructure. And there's also massive work on within the RAN Alliance. If you think of the RIC, this radio interface controller or radio intelligent controller, they have a number of apps and the studies, and then the specifications and implementation of them is ongoing. So many things already planned and coming into the current network releases. But I think the most interesting things will have to be specified and arriving with the 6G through mainly the fact that we are expecting to be a cloud native infrastructure with therefore ability to exchange services with AI workloads, enhanced security also embedded into the infrastructure. And here we are thinking of massive adoption of generative AI, which I can also explain the difference with respect to the discriminative AI, which is now currently heavily implemented and supported by our infrastructure.
Yeah, okay, actually, why don't we get started there? The difference between GenAI, discriminative AI, and different types of machine learning, how do you see them fit? Because sometimes people just assume that GenAI is the new version of AI, which is not quite right. So, David, why don't you get started and then probably can.
So generative AI is novel. The novelty, because in other fora I said they have studied all the algorithm, it is nothing new. There are new aspects, and the new aspect mostly relate to the fact of the ability of this algorithm of generating new content. So which is not discriminative, it's not about pattern recognition, it's not drawing conclusion about something you already have. It is something which is derived from the, say, the training data. You are creating with these new fundamental models latent space, a new way of representing and embedding the reality. And then you have a sampling, and then through this sampling, you have ability to generate new content. There are 5, I think, main, at least based on what we are using, main models, which I can quickly review, so that then we can explain the applications. So the first model is the variational autoencoders. So there, basically, we have ability to sample, create this hidden space, and then sample again the distribution to generate new content. We do have application, for example, for anomaly detection and interpolations when we think of our data. We then have application of the so-called generative adversary networks. So you have 2 competing neural networks that have ability on the one hand to generate information, on the other hand is to verify whether the information is true or not. And then in the long run, once trained, the entire algorithm has ability to generate synthetic data. Here we have a number of applications because data is always unavailable. So using the ability of generating data as definitely a number of applications. Then the third algorithm, I'm thinking of the transformers. Transformers, they have a great success. You may think of GPT or other model, LAMO. So their ability to extract information from an input sequence and then generate a new sequence. So anything that goes from sequence to sequence, definitely the transformers have something to say. Then beyond that, what we have investigated and continue to work are recurrent neural networks. We know we have now transformers, but there are specific problems where we are still using recurrent neural network, particularly the LSTM. So the one that they occupy a very little memory. And then beyond this, we are now adopting diffusion models. So diffusion models are extremely powerful when you think of generating new images. How they work is extremely simple. So you have the samples, then they bring noise, and then they make emerge noise. It's sampling, again, sampling within the hidden state, generate new images. And the last algorithm where we are in now is JEPA. JEPA, that stands for Joint Embedding Predicting Architecture. And this is revolutionary. It's revolutionary in a way that the other models of GenAI, they stick to the input information. So I am after images, I'm after text, sound, whatever. Whereas the JEPA, they have a joint embedding, and they are after the prediction of characteristics that matter to me. So I have a joint representation of the relationship, which I can then predict. So I'm using much less data, and it's extremely, extremely powerful, even thinking of anomaly detection.
Great. So let's get Paul to cover the other half of the, well, I don't know if it's half or whatever, but the discriminative AI, and then let's see how it works.
Yes, I mean, I guess, you have probably three main categories there, right? So you have, models that you use for classification. You have models that you use for regression, and then you might have some reinforcement learning, whereby basically you train an agent to learn a policy to act on an environment that is under constant observation. So I guess, the task is limited in a sense that you're not really generating any synthetic output based on the observations, but you're mostly trying to reason about the data that is presented as an input. I think that's kind of the main difference there. And it makes sense in very many applications. So if you want classification, I think David touched a bit on security. So if you want to, let's say, identify, some malicious flows that flow through a network, it makes sense to look at some neural nets that are able to, detect some subtle patterns that are basically indistinguishable from benign traffic for a network engineer, just because, you know, the way they are crafted, or just due to the fact that you have sheer volumes of information going through your network. Or if you want to do prediction, so you're trying to understand whether there are any sort of temporal correlations from which you can learn to anticipate how a signal of interest will evolve. Yeah, so that can be throughput, it can be latency, in essence, any KPI that it will be relevant to another downstream task that you probably want to fill with those forecasts. And then with reinforcement learning, things are, yeah, you might actually have a model that actually, you know, does some pattern recognition, and then, you know, that's your agent, and then the agent, what it does, it samples some key information from the environment. So let's say you're looking at, maybe you're looking at throughput and you're trying to figure out a way of configuring a radio access network to reduce energy consumption. So basically what you're trying to do is, when you see some patterns, how can you come up with a policy that will basically output a control signal that would influence the configuration of the network. And that's like a big field, and there's very many challenges to do with the convergence of the model, stability, and so on. I think GenAI is pretty much a different breed altogether. Yeah.
Yeah, and like I said, they both have their place, and I think it's interesting the way you're putting it. So it's not that either of them is a monolithic. You know, you don't just
No.
get AI, ML, or Gen AI, whatever it is. and
Actually,
you
the
plug it
success
in.
stands on the combination of them, meshing them, and yeah.
It's an open question, but I don't see them as sort of competing. It's not one or the other. It's one and the other for different purposes. And I guess we're still, you know, the industry is still kind of working conceptually
Precisely.
on that.
Yeah.
Yeah. So
Yeah,
how do you see
complementing
that?
technology.
How do you see those two or three different, well, these different paths going on as we progress in terms of what's more valuable, or what's where is that we are more ready to go, and what is that's going to take longer, and what are the bigger challenges? Is it security? Is it trust? Is it reliability? Power consumption? What do you see happening in terms of the high level progress here?
There's many things to think about. So trust is one, and that will probably speak to explainability. So if you're not able to kind of reason about the decision of a model, especially if it's involved in some critical task, I think that's typical. It should be critical for any sector that now provides some fundamental functionality, and networking is becoming one, right? Probably energy grids are similar. So data quality remains a big obstacle. There's a lot of data out there, but not all of it is useful. There's a question about data representation. So maybe you have a lot of data, but you don't need all that data to train a model. Maybe you can come up with like a method to figure out a subset of that data that you use for training, which provides sufficient features for a model to learn, and that removes a little bit that sort of big data, training data barrier. Computational power is one. So, you know, if you look at GenAI, there's a kind of, you know, a common acceptance now that the larger a model, the better it will perform. And now people are starting to look at like small language models, which are more sort of specific to a very niche use case. And then you try to reduce complexity as a sort of as a result of that. And I think that's super important, because eventually, let's say you're trying to use some AI to, you know, optimize the energy consumption of the infrastructure, and then you're spending more energy training those models. So you're shifting the problem from one location to the other location. So it makes sense to think about techniques to, you know, simplify the models that you build, there's been a lot of work in other disciplines like image recognition and natural language processes where you're looking at model compression, pruning, and so on. Yeah, I think, and then there's this robustness to adversarial manipulation. So people, when they think about security, they just think about, you know, a network will be breached, and then as a result, you have, you know, information leakage and so on. Or you're thinking about, you know, somebody might infer what the data that was used for training would look like. But there's a bunch of other challenges. So let's imagine I can figure out how a classifier works, and I can craft some adversarial input to fool that classifier. Let's say I have different types of traffic that are treated in different ways, and there's a price tag for their treatment, right? So now all of a sudden you have a customer that actually doesn't want to pay for the premium service, and they learn how to introduce some subtle manipulations to their traffic flows so that the classifier will treat it as it's like a premium service. So that's kind of, you know, it has some consequences from a financial perspective. So you have all these adversarial manipulations, but in the same vein, you can create adversarial manipulations that will compromise an intrusion detection system. So malicious traffic will start to look as benign traffic, and that can have some serious consequences. So yeah, I think these are probably key things that have to be looked at quite carefully in the coming years.
And I guess AI can actually fix some of those problems as well, because you can run AI on AI. I guess it's like infinite regression thing we hear about, you know.
I think it's an opportunity to look at also some of the, you know, some of the existing tools that people have used for other purposes. I'll give you one example just because I talked about all this adversarial machine learning. So one thing we did recently in my team, we actually looked at some techniques from signal processing domain when we're trying to understand, because in the end, like, you still want the core features, right? So basically I'm trying to simplify things, but what we're trying to do some energy-based spectral filtering of that input, because all these adversarial perturbations will have very small energy. And if you're able to filter them out, then you're able to basically protect that classifier and ideally not even have to retrain it. So you see, I'm using like a pre-processing technique, which is not AI, which is actually nice because it's super lightweight and it will be easy to deploy and it will not require me to change an existing system. So that's one approach. Yeah.
David, what do you think? The future.
I think that the main, so what will limit AI, thinking of GenAI or the evolution of these foundation and models we're having today, are only two things. One is scale, so availability of data, but that's not the point. I think the main point, as I agree with Paul, is the quality of the data. So how do you basically make quality data available? And I see also in my team, they spend 95% of the time in creating the data pipeline, and then in a few hours, they deliver you the algorithm. So that's the data availability in terms of scale as well. But the most important thing is going to be the energy. So I have also published an article on it because I was fascinated by the fact, but how much energy this model they consume, not only by the way during the training phase, but also the inference. So when you upload a very complicated context, you may see that takes time, right, before you get an answer. And now the context is becoming extremely large. So there's a lot of compute behind. And we will end up having the needs of a nuclear power plant of a gigawatt, because a gigawatt, because this is really the limit. So the limit is scale and energy. Energy is definitely as of today the end of the story. So that is really now. Perhaps I would like to share so the main issue I do see coming. I do agree with Paul, particularly focusing on discriminative AI. Looking at GenAI, I think there's still algorithm not working perfectly, so they hallucinate. So when you sample the hidden space, you may always have a problem to say, okay, but it is really true what comes out with it. The second is the biases, because you can be really thinking of applications more close to the customer, whether that is a B2B or B2C. You may have really bias algorithm that they drift you, or they pull you into directions not always, say, appropriate or even legal. But looking forward, I'd like to add one thing, because I do see, thinking of 6G, but also application on the evolution of current mobile network, three main directions coming, if I'm allowed to explain them. So GenAI will find massive application for data compression. Data compression, thinking that the latent space after the embedding is reduced in size. So I can send my embedded type of information and then reconstruct that using decoders at the other hand. So we think of semantic communication. For instance, instead of sending an image, I could describe the image and then use a transformer. I could rebuild at the other hand. It remains to be seen what we can do on the device, but I believe there will be massive edge AI, because it's not just about smartphones. Yeah, 6G will connect robots, we connect cars, vehicles, drones, and so forth. So that's one application. So compression, semantic communication in a way. The second application is about the ability of generating synthetic data. And here you may think of these GANs, but also the evolution of the GANs, combination of various technologies, that you will have a few samples and then you can draw conclusions by generating new data. You may avoid drive tests. You may explore further the problems you're having in your network. You can analyze your customer and so forth. And then the last application you see coming, particularly now with the JEPA, is the ability of predicting. Because if you think of JEPA, they have ability, as I said before, to look at the relationship between data. And therefore, with little amount of data, you have this immense capability of predicting new things and identify anomalies and do many things that other models don't do. And they will find application definitely on 6G and the evolution of 5G mobile communication systems.
Now let's move a little bit to something that I'm sure is on everybody's mind. So a lot of people are excited about what AI can do, but the excitement is not quite enough. You want to make money, you want to be profitable. So is AI going to deliver on that line in terms of either profitability or is it a monetization opportunity? And is that going to be better with 6G? What's happening already with 5G is going to be better with 5G Advanced. What's going to happen to 6G? So, Paul, what do you think?
Yeah, so there's probably two strands of monetization there. So if you want, you can think about, the fact that the industry, I think, still lacks quite a lot of expertise in AI. So you can think about AI as a service whereby, you come up with some interfaces and then you adopt AI from third parties. So those third parties will be able to monetize models. For the network operators, I think the opportunity is to use those models to, I guess we talked about energy. David mentioned that, which is a big challenge. I think that's probably the bigger barrier to revenue growth. At the moment, energy expenditure is it's outpacing sales growth. So if you're able to reduce energy consumption using AI, that's a win. If you're able to use AI to automate some processes and reduce engineering related OPEX, then your profit margins will grow. So if you want, it's not like you're gonna have a network that behaves better and then as a result you're kind of, I don't know, to some extent you're monetizing that AI that is embedded. It's kind of the other way around. Adopting AI will allow you to basically increase your profit margins because you have sort of lesser OPEX.
David? So what
Yeah,
about?
so perhaps it's not strictly specific to 6G. What 6G must have in place are the exposure ability of any sort of API, so that there should be a communication between the connectivity layer and the AI platform of any kind that could support even a hybrid type of solution where I have ability to integrate services for multiple agents. So say use the so-called agentic workflow type of application. That is definitely something we're expecting from 6G. Now, thinking of AI in general, I see three key benefits already we are having in place at the Rakuten Mobile. First is definitely cost reduction. So you may think of automating all your business processes, particularly with the integration with transformers or the variational autoencoders. So definitely we have massive cost reduction within our organization. The second is risk mitigations and recovery capability. So that's also something that you say does not monetize. It does monetize. Any incident could cost you whatever, so that the robustness of the network availability is all enhanced by using AI. That's definitely another. Then thinking of the revenues, there are also, I think, great opportunities because you may think of generating targeted advertisement, but beyond that, you may study your sentiments or why your people are churning, identify the trends, and then generate new content or new ways of dealing with your customer. For example, at Rakuten, what we do now is not only we have chatbots for communicating to the end users, but we try to understand the semantic behind the prompt we are receiving for our customer. So in that sense, I think the customer experience will improve, and potentially you'd also have ability to increase your ARPU, right? Because you receive these services as an end users, you may be assisted online through your fantastic communication services. You are for sure also willing to pay more at the end of the month, or even generating services to third party, as long as you have ability to expose your APIs and monetize them as well.
Excellent. Our time is up, but thank you for the conversation. And we heard that you can become more efficient, save OpEx, get some more revenues, and be able to talk to someone in customer service that understands you. Wouldn't that be a beautiful world? Well, thank you so much, and thank you all for the audience for listening in.
Thank you.
Thank you.